So this video is the green book, number 13, that's the one we're doing, HOCN. So let's go ahead, write it out. HOCN plus HOH gives you H3O plus and OCN minus. So the hydronium ion concentration is so forth, and it's a 0.1 molar. Calculate the ionization as well as the pH. So we're figuring this stuff out to be at the equilibrium. So either way, it's the same thing. So the pH, if you know that the hydronium concentration is this right here, so we can plug that into the negative log and we should get a pH of 2.24. That's easy. And then the only tricky part is that's the concentration of here, 5.74 times 10 to the negative 3. Well, that's also going to be the same thing here. And then this we have as 0.1 molar. So let's plug that in and figure out what the Ka is. So we have 5.74 times 10 to the negative 3 squared, because you have both of them, and then divided by 0.1 molar. And we should get a Ka value as being 3.3 times 10 to the negative 4. So number 16, phenol is a very weak acid. pH is equal to 5.61, and the molarity of a phenol solution is that. Calculate the Ka. So pH is equal to 5.61. So 10 to the power of negative pH gives you the hydronium concentration, which should be equal to 2.5 times 10 to the power of negative 6. So we have our hydronium concentration, and now we're trying to figure out Ka. So we can write this out a certain way. We can do the same thing. Plus HOH gives you H3O plus, and then the anion, which would be just C6H5O minus. There's no space here, so I'll just leave it blank. The concentration of H3O plus is the concentration of that anion, and we found the concentration here. And since Ka is equal to the products, we're just going to go ahead and square that. So 2.5 times 10 to the negative 6 squared, and divided by the equilibrium concentration of phenol, which is 0.215. Ka is equal to 2.8 times 10 to the negative 11. Number 17, a solution is that prepared by dissolving 3.75 grams in 250 milliliters. pH is equal to that. So if the pH is equal to that, 0.89, then the hydronium concentration is equal to 0.13. And then as far as figuring out the molarity, they're making it a little bit trickier by making us actually solve for it. This big thing right here, the formula weight for that is equal to 75.03 grams for every mole. If you were to plug in the 3.75 grams, what we would find is that we have 0.049 moles. There are 0.25 liters. We're trying to figure out the molarity, trying to get this to 1. If we do that, we should get this to equal 0.19 moles. There are. That is your molarity. So that's the only tricky thing. And the first question they actually gave us the molarity, and we solved for A right now by figuring out the molarity, and now we're figuring out the Ka. So since we know the hydronium concentration is 0.13, that's also going to be the concentration of the anion. So it's just, once again, 0.13 squared divided by the concentration of the first, 0.19, and we should get 8.7 times 10 to the power of negative 2 as our answer. And we're done.